Hello everyone to this new step for this chess game. In previous videos we figured out how to create the board, place the pieces and place the right pieces in the right place. So now we are going to actually figure out the available movements a piece has in the board. To do so, we are going to start creating a method somewhere. So, for example, let's say test pawn movements. So with a default board, for example, let's create a method that figure out the available movement for example, for the coordinates. Let's use point int instead. The available movements for a specific point, for a specific piece, will say will provide a list of available movements. And those movements would be positions in the board that will also be point int. So for example, for the pawn, or let's start with the knight instead. So the knight is going to be able to be placed here and here. So this should return something like 0, 2 and 2, 2. 0, 1, 2, 0, 1, 2 here, 0, 0, 1, 2 here. So the available movements for this piece is going to be these two. So the thing is, let's create this method, position, so let's actually support using this to get the cells. So first we are going to figure out the kind of piece, the cell we have here. So let's for empty we are going to return an empty list since no movement is available for that cell. And for pieces it will depend on the kind of piece. Every piece has their own rules. So let's use the kind, and let's start with the knight. Let's start test bishop movement. This is the knight, knight movement, and this should fail without to do, and we are going to implement this. So in the case of the knight, we should provide this current position. This is going to be a list of a list of this position minus 1, 2 plus 1 minus 2, and the same here. Let's actually place a knife here. So here, for example, we would also be able to move here, here. Actually, there are like 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 possible positions. So it's like we are moving 1 to the top or 2, and then doing the other thing. Let's hard code them for now, but we should be able to actually not hard code them somehow. So this is all the possible positions, but not all of them are valid. So we have to verify which of these ones are valid, and this is going to be valid position, valid empty position. So if the position is outside the board, that's not a valid empty position. The same goes for if it's outside this. Actually, we can do differently. We can use ranges, and otherwise is valid. Is this true? No, it isn't, because if this position is chess cell empty, this is also an invalid position. So it's valid if the coordinates are valid, and so let's say, let's make it a single expression. Something like this. So if the x is in a valid position, the y is in a valid position, and the cell is not empty, this is a valid empty position. So now we are going to actually filter the return values here with this function. So we are providing valid movements. So this is saying this is not working as expected. Why? We are doing the knight, and the knight is in the 1 and 0. So +1 is 2 and 2, 2, 2, and y 3, 1. Let's not filter this. So 2, 2 is here, and 0, 2 is here too. So sorry, its valid empty position should be this, equals. So yeah, now the problem is the order, so let's maybe sort by x, for example. So we don't depend on the order, or maybe we can, instead of a list, we can return a set. Set of, so the order is not important. On this set. So now we have this movement for the night. And yeah, this is it. Let me, before wrapping this video, because this is going to be too long, I'm going to try to represent visually in the board the valid positions here. So let's say we want to get events. Let's place here a text with the position, but we are going to, well, actually, let's create a container here, and this container, we're going to use this container for representing this board and these images. Okay, so we have the position here. And color, something like this, and let's put a shadow or something. So it's a bit better in terms of drop X. And blue radius, let's say 1F. Something like this for now. Okay, so this, we are going to place the position of the board when we move the mouse here. So let's use mouse here. We actually have several options, but let's we should maybe sorry, no, this was not the problem. The problem is that here mouse move on mouse and move. Okay, so this is giving us the position of this cell. Let's use a higher value for this text. So this is the position. So now when we move to a specific position, let's say we are going to use this board available movements for this point int XY movements, something like this. So as you can see, this we are getting errors here, exceptions probably. I don't know where is this running. And where is this? We are running this. I want to check the. Well, let's use this, but there is. Well, let me rerun it. Here it was. So here we are getting the exceptions here. This is working, but for other PCs it is not being updated because of the exceptions. So let me empty list. So here we could use this to place some images here. Some like placeholders to visually figure out where we can move the cells. But this is going to be in another video, in the next video. So see you in the next video.